Oh my gosh, I had the whole video recorded and then the computer glitch erased it all. That's too bad. So let me start over and try and make it fast. Here, you got this real life situation where lightning strikes and you see the flash immediately, but the sound takes longer than light to get to you. And you can actually use this to figure out how far away the lightning struck. Okay, but here's the fact, and this is actually how lightning and thunder works, is that if you are 2 miles away, it will take 10 seconds from the time you see the flash to when you hear the crack. And if you're 3 miles away, it'll take 15 seconds. So what's the general rule? Well, we have ordered pairs to say, okay, if the distance that you are is the independent variable, you're 2 miles away, and then therefore, as a result, it takes the thunder 10 seconds to get to you. That's a data point. Okay, and here you have 3 miles away would take 15 seconds. And fun fact, if you were 0 miles away, it would take 0 seconds for you to hear that crack and feel that strike, because that would mean you're right there where it struck. Okay, these are all data points. Now, what does that mean? How many seconds does it take to go a mile? Well, if it's 2 miles, it takes 10 seconds, and 3 miles takes 15 seconds. You can imagine that it takes thunder takes 5 seconds to travel 1 mile. Okay? And one of the things that you're going to note about what our lesson is today is that we're always going to have, for the type of problems that we're dealing with right now, 0, 0 is always going to be a set of data points or a set of coordinates. It's always going to go through the origin. When one variable is 0, the other is 0 as well. Okay? So keep that in mind because we're going to need that. Okay, so as I just said in that example problem with the lightning, is that you always have 0, 0 as one of your data points. Now, um, keep that in mind. Now, if the ratio of two variables is constant, then we have a special relationship called a direct variation situation. Okay, direct variation is a relationship that can be represented by a function like this: y equals kx. K is not going to be 0. K is some other number, positive or negative. Okay, and when you multiply x by that number, you get the correct value of y. Okay, and the constant of variation is that k number. Okay, k is the coefficient of x, or the number that sits in front of an x and multiplies it. Okay, now watch what we can do. You should remember from our earlier units that you can solve for one of the other variables. If you have something like this, y equals kx, you can then say, I want to solve for x. I'm sorry, I want to solve for k. Let's solve for k, and what's happening to k? It's being multiplied by x. So if I was to then divide both sides by x, just to get k all by itself, we would get k is equal to y divided by x. And we're going to need that in a moment. And that's right here, so I'll leave that there to refer back to it in just a second. Okay? But if we knew one of the data points, not 0, 0, but one of the other ones, we could actually find that k number, and we will need to do that. Okay? And then once you found it, you could write the proper equation y equals kx, but instead of writing k, you'd write the number you found. And that would help you then find other information. Okay. So to determine whether an equation represents direct variation, it says solve it for y. Okay, and if you can write it in this form without any other extra numbers on there, it's direct variation. Another way that you can do it is to plug in 0 for x and 0 for y, because we know that 0, 0 is always going to work for these direct variation situations. So if we plug in 0 for x and 0 for y, and it works out to be true, we get the same number on both sides of equals, then we know we're dealing with that kind of situation. Okay, so here's a problem. Okay. Does it represent direct variation situation? Well, the first thing that we could do is we could say, okay, I'm going to rewrite this equation in this form, y equals something x. And in this case, what we're doing here is we're dividing both sides by 7. That's what is in front of y. and you need to get it down to a single y, so you say 7y divided by 7 and 2x divided by 7. What you get is y equals 2/7 x. And since that is in this form up here, y equals kx, where you can see the k in this particular problem is 2/7, this is one of those situations. Okay, now this one, if you tried to rewrite this, subtracting 4x from both sides, and then dividing everything by 3, you could see that it doesn't work in the form of y equals kx. We have this other number here. Okay, so that's not direct variation. Another way you could do it, though, is to plug in to this original problem, 0 for x and 0 for y. And 7 times 0 is 0, 2 times 0 is 0. Yeah, that's true. So as you can see, this is a direct variation problem. And we'll do something with that in a second. Okay. What about this one here? Well, if we had 3y plus 4x equals 8, and we plugged in 0 for x and 0 for y, does it work out to be true? Well, 3 times 0 is 0, plus 4 times 0 is 0, equals 8. 0 plus 0 is 0. Nope, that's not true. Okay, so this is not a direct variation situation. And so we can't even do what we want to do with this problem. But we can do it with this problem over here. And so let's do it. Let's say, okay, we can then rewrite this as they did already by dividing both sides by 7 to get it in the form of y equals kx. This happens to be k for this problem. So the constant of variation is that. Yep, that's it. So now you got a problem. Let's try it. The question for you is this a direct variation situation? And if so, find the constant of variation. If it is, you can plug in 0 for x and 0 for y, and it will work out to be true. And if it is true, you'll need to rewrite the equation like this: y equals kx, where you have to get this off of that side and then divide everything by 5. Okay, give it a try and see how you do. Okay, so if I took that equation and I plugged in 0 for x and 0 for y, we get 4 times 0 plus 5 times 0 equals 0. 4 times 0 is 0, plus 5 times 0 is 0 equals 0. Yep, 0 equals 0. This is a direct variation situation, so we can rewrite this. How do we do it? Well, we take the original equation, 4x plus 5y equals 0, and we're going to first subtract 4x from both sides. What we get as a result is 5y equals negative 4x. And so we will take that and we will divide both sides by what's in front of y to get it down to a single y equals. And what we get then is y equals negative 4/5 x. And the constant of variation is whatever's sitting in front of x once you write it in the y equals kx form. So that means that k is equal to negative 4/5. Okay, so you can actually find the constant of variation, the letter k, by taking some data values, where you know what y is and x is, and you divide y divided by x. And remember, if we took this original equation and we solved for for k rather, by dividing everything by, in this case, x, you would find that k is equal to y divided by x. So that's how we can find it. We can find the k value by doing y divided by x, as long as we know that we're dealing with a direct variation situation. And in fact, in this particular problem, they tell us right here, you can suppose or you can assume that y does vary directly with x. This is a way of saying this is a direct variation problem. Okay, suppose y varies directly with x means, yep, we're dealing with direct variation. Okay. What does that mean then? Well, we can take these values and divide y divided by x, and we can find that k value. And if you do that, y divided by x, I'll write it in here, is 35 divided by 5, which is equal to 7. Okay? So by doing that, we say, okay, there we go. We've got k is equal to 7, so now we can write the equation as y equals 7x. The way that they did it is that they replaced y and x with their respective values here and just solved it out. You still get k is equal to 7, and so you can put that where k is in this particular original formula, put 7 where k is, and you get this specific equation for this problem. And now they're asking, what is the value of y when x equals 9? Well, if we already know what the equation is, y equals 7x, then we can just say, okay, they're saying up here, we need to find out what y is if we used x equals 9. So we can then do that, like that, and we solve it, and we get y is equal to 63. And I don't know why that moves around like that, but if that's true, then y equals 63. And by the way, if you look, that's what they have right here. Awesome, we did it. So now you're going to try your got it problem. Suppose y varies directly with x. This is, I'm reading this got it problem here, which means that it is a direct variation problem. Then you can find k by dividing y divided by x. So find out what that k value is and then write it in this form, but replace k with whatever number you find here doing this divided by this. Okay? And then the equation y equals that number x is the equation you want. Use that equation and replace x with negative 15 to find out what y is. Do that right now. Okay, so we can say, okay, we know that y varies directly with x, so it's one of these types of situations. So we can then say k is equal to y divided by x, or k is equal to, in this case, y is 10, and x is negative 2 is what they told us. Oh gosh. My iPad is dragging, and so when I write things, it delays and then writes a whole bunch of stuff. Okay. And we find out that k is equal to negative 5. That is the constant of variation, so we can write the equation then as y equals negative 5x. That's part of our answer. This is part of our answer. K is equal to negative 5. This is also part of our answer, where the equation is y equals negative 5x. And then we can use that equation and say, okay, what do we get for y when x equals 15, negative 15? So we say, okay, then let's substitute x with negative 15. And we get y is equal to positive 75, and that's the last part of our answer. Okay, so I'm going to move quickly through this. Remember, all right, so first of all, they're telling us the weight on Mars varies directly with the weight on Earth. With y varies directly with x. It's one of these situations. So if we wanted to write the equation where we knew what k was, we can do y divided by x. And y is your weight on Mars. Here it is. Divided by x, your weight on Earth, because that's what they say over here. Weight on Mars is y. Weight on Earth is x. So y divided by x is 50 divided by 130. K is going to be equal to 50 divided by 130. And you can either get the exact fraction, 5/13, or you can get an approximation, which is what they did, of 0.38. So then you say, okay, then my equation is y equals 0.38 x. And if you wanted to graph this, you'd need to get a couple of points. We know that 0, 0 is already one of the points. That's always one of the points. Okay. And of course, you could also just use the coordinates for x and y. X is your Earth weight, 130. So we have one data point is 0, 0, and the other one is what they gave you. Your x value, weight on Earth, 130, and your y value is your weight on Mars, 50. And all you need is 2 points in these. So you could go, okay, I'm going to put my point down here at 0. I'm going to put my point here at 130, 50, right there, and that would be enough. And you can see they're both on that line, and you could connect them. Or what you could do is what they do, which is make a table and say, now that you know that this equation, you can pick some values for x, plug them in, and find out what your matching values for y are, and you can make an ordered pair of this comma that and plot them. Okay. I'm going to keep moving. I know this video is long, so I'm going to just keep moving past your got it problem here, but you can stop it and try it if you like. So this is basically just a summary of what we have learned, which is the graphs of these things are going to be passing through 0, 0 always. They're always going to go through the origin, okay? And if the k value is positive, that means and see where it says k is greater than 0 or positive, that means your line will rise to the right because this is your slope. This is the slope of the line, okay, or how the line is tilted. From here, as x goes up, so does y, and that's a positive slope. Here, when k is less than 0, or this k value is a negative number, we're going to have a negative slope, and it's going to drop as you go to the right. Okay, so you have graphs looking like that. If the k value is positive, it will rise to the right because the slope is positive. And if the k value is less than 0, or meaning the slope is a negative number, it will drop to the right. Okay. You can, of course, rewrite it, y equals kx, as y over x is equal to k. Okay. And when a set of data pairs varies directly, you can do y divided by x to get the constant of variation. And it should work the same for every pair. So let's do one last problem and see what happens. How do we verify that we are dealing with constant of variation problems? Okay, so the way that we check it if we're given a table is they're asking, does y vary directly with x? Is this type of problem? Okay, if it does, then write an equation in the form of y equals kx. Okay, but the trick here is that we can say, well, we will know the k value if we do y divided by x, but it always has to be the same. So let's do it the same every time. Let's take y divided by x, 6 divided by 4. That equals 3 over 2, which if you turned it into a decimal would be 1.5. Okay, what if we did 12 divided by 8? That also simplifies down to 3 over 2, which is 1.5. And we could do 15 divided by 10, and we would get 3 over 2, or 1.5. We always get this number, which means we are dealing with a constant of variation situation, and so we can use that number for k and write y equals kx as y equals 1.5x. Okay? Now, on this second one, you can see what happens here is they say, okay, let's do y divided by x. Let's do 3.2 divided by negative 2. And as you can see down here, what they get is negative 1.6. Okay, doing it again, that was for that one. Doing it for this one, we do 2.4 divided by 1. Anything divided by 1 is the same, 2.4. That's what they got here. You can see we're not getting the same number. That's a problem. And the last one, 1.6 divided by 4 equals 0.4, which is right there. That means this one gives you even another number. We're not getting the same number every time, so this is not a direct variation situation. That's what that says here. So this is not one of those problems. Okay? Find out right here for this got it problem. Is this a direct variation situation? If so, then when you divide this divided by that, every time you should get the same number. And if you do, that's your k value. And you can write it in the form of y equals kx, where you put the actual number you got each time for k. Try it right now. Okay, so for these data points in red, it was 2.25 divided by -3, and that works out to be -0.75. For the data points that I circled in blue, you're doing y divided by x, or -0.75 divided by 1, which is -0.75. That's looking good so far. And the final one in green is -3 divided by 4, which if you actually turn that into a decimal, you get -0.75. Every time we get the same number, and therefore that is it is a constant of, it is a direct variation situation, and that's the constant of variation, and we can then write it as y equals that number, -0.75x. That's your answer. Okay, so I've lost access to the teacher edition of the book, and so I don't have the answers easy to screenshot and post right here. So I'm going to add them on later in the video. So right now you might look at these lesson check problems and you don't have anything to check it against. But if the video stops and there's answers at the end, you can go back and try them and check your answers. Okay, I'm going to add them on later. So anyway, that's the lesson. Hope that made sense. Ask me questions if you need to. Good luck.